Hello again, and welcome to part 2 of building a Spring animation engine from scratch. Last time we got the basic thing working. Here you can see the circles jostle about. But now we're going to make it more production grade because there are a few ergonomics issues, a few blights on this API, and we'll just quickly enumerate them in order of obviousness, conspicuousness here. The first one probably being this big honking timeline view that sits right in the middle of everything that actually kicks off the animation. This shouldn't be exposed to the user. This should be an implementation detail hidden away somehow, somewhere behind the scenes, and it should just work. Getting the right time delta, updating things when they should be updated, no more, no less. The next problem is this. Whenever we want to access the current value, we have to say .value or .animate. It would be nice to maybe use a property wrapper to hide that away and have that just be boilerplate. We can look at how to do that. Basically changing this thing from @state, where we have to then instantiate the SpringDouble or whatever class we end up with, we can just say @animated var offset spring equals 200, and that should just work. So that would be the ideal goal, something more like animated. If we could get that to work, that would be just gorgeous. And the final blemish is maybe not too obvious, but here we're using SpringDouble, and we've hard-coded the double value inside of here. So this will not work with CG point or CG rect, or maybe our own custom types, colors, etc. We want this to be extensible. We would like to figure out a way to abstract over this value here and have it work with really anything, even user-provided values. And to do that, we're going to create a vector arithmetic protocol. That's what SwiftUI actually uses, and we'll explain that. It's actually a fairly simple abstraction that falls out of what happens when you change double to a type parameter. And so by the time we've done all three of those things, we should have a pretty decent API on our hands that we can, publish as a library or do whatever with. So let us begin. So let's start with this usability issue where we have to call methods, call functions on our SpringDouble type like animate to change it, or we have to manually access the value property versus being able to sort of treat it like a normal value assigned to it as we please and have that sort of just work, to not have to think all the time that we're dealing with some special SpringDouble value. We want to be able to work like we're accessing the underlying value directly. And in SwiftUI, we have a tool for doing this. In fact, that's what all of these property wrappers that we use in SwiftUI allow us to do. We're not merely updating this offset value directly, this last state directly, etc. What's really happening is that there is this state struct, which internally contains a date or an offset. But in order to avoid some really unsightly boilerplate, much like this, Swift has this property wrapper capability, which we'll use to make this really nice and basically achieve an API like this. Now, we will still need to, in this background view, call this update method, but we're eventually going to be hiding this altogether, so we won't have to worry about exposing something so unsightly to users. Okay, so I'm going to copy that. So we have our little target, and we can just toggle between which line is commented once we've solved this problem. So I'm going to scroll up to our definition of SpringDouble, and there are a couple of ways we could do this. As usual, we could make this class into a property wrapper directly, but it might be nice to keep this class distinct and not have to worry about fusing the property wrapper API with our Spring value API here. So let's make a new property wrapper above, and I'm going to say property wrapper, and I will call this animated. And we're going to need to make this a dynamic property. I'm not going to go too obsessively detailed into my description of property wrappers. That will be for a video for another day, but I'll at least talk through what I'm doing. By doing this, we're going to be able to write something like @animated, just as we can do the same with @state, and this will prefix a var. So we can say @animated var offset, and have some double value in there, or whatever other value we so desire. And just like with result builders, this is actually syntactic sugar that's going to get rewritten at compile time into something like this. We're not going to have that attribute. Instead, it's going to have an underscore prefix. It's going to be a value of that type we're constructing, and it's going to construct it by taking whatever value you had to the right of that equal sign and calling an initializer with the wrapped value label passing in that value there. And so we will need to create that initializer. I will say init wrapped value. We want to accept a double for now. And then we of course need to store that value somewhere. And where exactly we're going to store that? Well, we're going to make ourselves a SpringDouble internally. So I'm going to use an @state property wrapper here, var SpringDouble, and this is going to be a SpringDouble, and we'll initialize one with our wrapped value. Now, in order to get rid of this error here, we're actually going to need to implement a wrapped value property, a computed property here. So I'm going to say var wrapped value, and this is going to be our double that's inside of our SpringDouble. It's going to be the actual value here. So we're going to have both a getter, which is simply going to access that underlying value, and then a setter, which is going to sneakily call our animate_to method given the new value. And so what's actually happening is when you use @animated, not only does it instantiate one of these property wrappers, but also every time you refer to offset, it's essentially going to be calling into this wrapped value property on the underscored version. So it's going to be defining something like this as well, where the getter is going to basically call offset.wrapped value, and the setter is going to assign to that wrapped value with the new value. So the key thing to realize is whatever we define here as wrapped value, that is essentially how that initial variable is used. This is what gets called when you simply refer to this property nakedly, and when you assign to this property, this gets called the setter of wrapped value. Let me copy this, and we'll actually try this out now because I think we've written enough for it to work. So I will scroll back down here, and let's change our offset spring to instead be @animated equals 200. And now it says value type double has no member value. And that sort of makes sense because this is indeed a double. Why is that a double? Well, it's essentially rewritten offset spring to be the implementation of animated's wrapped value method, which returned a double. So it would make no sense to call value directly on a double. It sort of already is accessing that internal double inside of the animated property wrapper. And then there's one more error, actually a couple more errors. For this one, I can just swap this out. I did have one little issue. It says cannot assign to property. Self is immutable. So this is one little tricky thing that we have to deal with. Scrolling back up, we'll see that we're calling set here. And animated is a struct, and therefore Swift's very clever mutability checkers are going to realize that we are attempting to modify a struct that is not mutable. It is not used in a mutable context. However, we're not actually changing any of the values in our struct. We're instead changing a value in this reference type, which will not modify the struct. So it's actually safe to say non-mutating here in our set, which will get rid of that warning. It can be a little complicated. Just treat this as a ritual for now, and I'll have a more advanced property wrapper video coming one day. Let me know if you are interested in such a thing. But that got rid of that error. And then finally, here we're trying to call update on our double value, but what we actually want to do is call update on the SpringDouble inside of our animator. So to do this, I can say underscore offset spring, access the SpringDouble, and then call update on that. And there's actually a way of making this even nicer, which we'll look at in just a moment. But first, if this is confusing, let me scroll back up here. So as I mentioned, when I invoke a property wrapper like this, what's actually going to happen is at compile time, it's going to get rewritten from this to prefixing your variable with an underscore, initializing the property wrapper as a class, passing in its initial value as the labeled argument wrapped value, and then taking the wrapped value var computed property here defined on your property wrapper and essentially inlining it as such, giving it the name of your initial variable. So if we do this, we'll see that everything compiles just as it did before. Obviously, this is way uglier. It's not a very fun piece of boilerplate to have to write, and that's why we have property wrappers. It's way nicer to not think about this. And now there's one other nice thing that we can talk about, one other usability offering that property wrappers have for us, which is sometimes you want to follow a similar pattern like we are here, where there's some internal class that has the logic inside of it or something else, and you don't want to have to access that property property wrapper directly or work through it. You want to keep that property wrapper private. It should really sort of just be this intermediary that vends to you either the wrapped value or something else, something which is referred to as the projected value of the property wrapper. And you fully get to determine exactly what that is. In this case, we want it to be our SpringDouble, and we can essentially create an alias for that by using the $sign prefix. Now, it won't be in scope immediately. What we'll have to do is go up to our animator type and create a projected value computed property, just as we had the wrapped value. And in this case, I will say SpringDouble, and I'll simply return the SpringDouble. And now that we have done that, lo and behold, this works, and it is indeed a SpringDouble. So we have the underscore prefix, which is the property wrapper, the naked variable, which is that wrapped value, and then the $sign prefix, which is whatever you put as projected value. So you have a whole bunch of options here. With @state, the projected value is a binding. Underscore is the state property wrapper itself. And of course, just the naked variable is that wrapped value, which is the double inside of this state. So it's a little weird to write, but it gives a really nice developer experience. We don't have to worry about any of that complexity at the call site. We just get to nakedly refer to these things in a very minimal way. And we don't have to write any of this ugly boilerplate. Now, since we have a projected value in our property wrapper, the compiler will also synthesize a $sign offset Spring, which will basically be the implementation of that property wrapper. So it was Spring value. So something like that. So once again, some more syntactic sugar, kind of like a macro, a special case version that's built into Swift, and just offers a really nice API improvement in certain situations. And let's just quickly check that this still works, and it does. So just the same functionality with a nicer API is a pretty good deal. The next issue I'd like to contend with is the matter of hard-coding a double here. We may, as I mentioned, eventually wish to animate CG points, or CG sizes, CG rects, colors, or data types of our own creation. But right now, animated contains a SpringDouble, which itself assumes that the value and the target are going to be doubles. So if we also wanted to animate an X offset, or the radius of our circle here, these would have to be separate animated properties. And that wouldn't be as nice as merely being able to specify our target CG rect or what have you as the value and just have that automatically interpolate, which is of course what we can do with the built-in animation. So how might we get this to work? One fun way of doing this might be to take a type-driven approach. Essentially, what we can do is, let me copy our SpringDouble. We'll keep that around as a reference. And then on this one, we will simply take what is hard-coded and concrete at the moment, this value and target double, and instead replace them with a type parameter. I'll call it value, and I'll call this whole thing a Spring value as well. And now what we can do is, instead of accepting a double, we'll accept a value. And this will cause some compilation errors, which we can follow through. So, of course, value and target must both be of this new value type parameter. Animate must accept the next value if it's going to assign that to the target. And now we run into a pretty interesting error, which is that, well, we cannot call the infix minus operator on two value operands. Similarly, we cannot multiply the result of that by a double, and some other problems below. But let's just start with this first one here. So what do we do? Well, I'd argue that this strategy is actually a perfectly reasonable one when attempting to abstract some code that you've written. You can just start by getting all gung-ho and replacing a concrete value with a type parameter, and then when you run into this error, you take this as a sign to build a protocol. So the problem is our value types do not know how to subtract. Well, we will teach them by creating a protocol. I'll make a new protocol, and for lack of creativity, I will call it Spring Value Protocol. We can give it a better name later if we think of something. And then in order to be able to use the infix minus operator, we have to make a static func minus. That's a binary function that takes two arguments. A left-hand side of value is what we eventually want, but in this case, it's going to be whatever the thing that conforms to Spring Value Protocol is on both sides. So self. And we're going to return a self. So maybe concretely, we're going to accept two doubles and return a double, or two CG rects and return a CG rect, but we're not going to say accept one CG float, a CG size, and then return a view or something like that. They all have to be the same type, and they all have to be the type which is conforming to Spring Value Protocol. And now we can take the Spring Value Protocol and say that our value type must have conformed to this protocol, and now this line is cool. because abstractions can be a bit confusing, let's simultaneously make a concretion and extend our double preemptively here to conform to the Spring value protocol. And so we'll steal this, and basically we have to implement a case where self is double. And this is extremely trivial. Hooray, not so bad. Many of these implementations are going to be trivial. So now let's look at the next issue. It's a bit of a misnomer. Cannot convert value of type value to expected argument type double. So it wants us to sort of force convert this to a double. That's not the way to go. But we can reinterpret that error saying that there is no times operator on our Spring value protocol that accepts on the left-hand side a value, which is what this is, and on the right-hand side a double, which is what stiffness and damping are always going to be these scalar double values. And so we really don't actually want to implement a static func times asterisk here on our protocol because the left-hand side and right-hand side are different types. Theoretically, what we want to do is to take this displacement value and scale it by some amount, multiply it by the stiffness. So what we really want to do, and we can make this a little more concrete, is say we do have a CG point with an X value of 100 and a Y value of 50, and say our target position is 275. We'll eventually have some Spring value protocol for CG point, and when we get the difference here between value and target, we're going to get this displacement of -100 and -25. And we're trying to now calculate the spring force that is going to result from this displacement. And if we think about it, we want this to have a greater force along the x-axis than it would the y-axis because it's more displaced along the x-axis. So what we want to do is basically multiply pointwise this CG point by the stiffness and negate each of these values to figure out the force. So this spring force is going to be somehow the opposite direction. It's going to try to return to equilibrium by pushing against displacement, and then multiplied by the stiffness to give it a really powerful force, or whatever the setting is, maybe a really weak force. Multiply everything by 1,000 or something, if our stiffness is 1,000, -1,000 in this case. And because we can't simply have times 1,000 here, or times -1,000, because this really would be a strange use of the multiplication operator, instead we can make a new method, maybe call it scaled by, that would have that same implementation, but we can give it a nice unique name, where the value here will always be that scalar double, which will scale whatever our value is pointwise, or whatever makes sense for the particular implementation. So let's do that. I will make a new method, a new function here called scaled by stiffness, and then I will add it to our protocol. Func scaled by double, and it'll return another self. And in the concrete case where it is a double, well, now we can just use self times by. Maybe I can give this a name actually, scalar, so it's a little more readable. Apple would be proud of me here for using labeled arguments like this. And now I'm going to scroll back down, and there's a new problem, which is that unary operator minus cannot be applied to an operand type value. And we could add this unary operator to our protocol, but it would actually be easier in this case to simply move that negation over to the stiffness value. That'll also be a little less performant, because we'll just negate the double and then propagate along that to every value pointwise, instead of, if we had a negation unary operator, it would probably have to first go through every value pointwise, negating them individually, and then doing a second operation where we multiply. That's sort of an aside, but this is the same, right? You can have either -5 times 10 or 5 times -10, and that should really be the same. Oops, I deleted the minus there. Okay, so this is going to get us a spring force, which is a value. And there are some other issues below, but let's actually take a look at this next line. For the very same reason, if I bring back our point example of, let's say, x being 50, y being 200, and the target state being -50 and -200, whereas here each field would have its own individual displacement, in this case 100 and 400, 200 minus -200. Each field would also actually need its own individual velocity. Let me actually say, what if it started out in the correct x position, but was just offset along the y-axis? In that case, the displacement would be 0, and we would never actually want to have any velocity along the x-axis. We'll have to calculate some velocity along the y-axis based upon the displacement, according to Hooke's law, but essentially every point, once again, needs its own velocity. So we're sort of doing things in a columnar fashion. That's a great vocabulary word.
columnar.
Resembling an upright pillar or column. No, arranged vertically, that's the one. A columnar database. Word of the day, if you didn't know it. Okay, so the point here is that velocity must also be one of these value types, because every property of that value is going to need its own velocity. And this brings us to another fun compilation error. Cannot convert value type int to specified type value. Before, it was sort of automatically coercing this into a double because we had ascribed double here, so it wasn't really an int ever. But now that it's a value, we cannot use 0 any longer. Instead, every value will need its own custom concept for 0, and we can do this using the protocol. I can say value.0 here, and, well, value has no member 0. We can fix that by making a static var, call it 0, and it's going to be of type self, and it will just have a getter. And then we can do the same thing for double, have a concrete implementation. 0's double is going to be 0. Very exciting. Scrolling back down, that line now compiles. And now we're almost through ironing out these type errors. This is the same problem now. We cannot convert value to double as before, the same problem as this, and we just basically want to use scaled by again. We want to scale the velocity by the damping. We don't want to add a unary negation operator. Will instead just move that over to the damping. And now here is a real problem. We do not have plus on two values, but this makes sense. We want an infix plus operator for our value type. So I will basically copy what we have here, make a plus, and we will do the same thing here. Plus and plus. Great. Scrolling back down. And now it says plus equal cannot be used. And this is kind of hiding the real problem because now acceleration is a value, of course. And so we're once again trying to multiply our value by a time delta, which is going to be some fraction of a second. So I will say scaled by the time delta, and same here, scaled by time delta. But we still have the problem that plus equals cannot be applied to two value operands. We could fix this in a couple of ways. One would be to simply say equals velocity plus acceleration, or equals value plus that. We could sort of desugar the plus equals, and this will work because we have already implemented plus. However, that would be a bad idea. We want this to be pretty performant. We're going to be doing this 60 times per second after all, and plus equals does allow for the implementation to be a little more efficient. In order to implement this, we can go up to our protocol, copy the plus implementation, make it plus equals, and specify that the left-hand side is going to be an in-out parameter so that we can mutate that parameter, which will allow this to be more performant. And then down here, I will copy our implementation, make it plus equals, make this into an in-out parameter, and then we can simply say left-hand side plus equals right-hand side. And then of course for this version, we do not wish to return a self or a double because it's obviously modifying that in-out parameter. And now we're almost there, except we have this yellow warning telling us that these function calls cause infinite recursion, which does make sense. We are implementing plus in terms of plus, so this is going to call back into itself over and over and over again until we get a Stack Overflow error. Turns out, though, that we can actually just remove these altogether because these methods are already implemented on double. They come with it for free, so it will still satisfy the Spring Value Protocol even if we do not explicitly add those functions in here. But if we implement this for another type, which we will do momentarily, we will need to have these methods. So maybe I'll just comment it out. But now everything is compiling, at least down here. We have now fully abstracted, genericized this update method, and the next step would be to actually use it. A good way to force this to occur would be to just simply go up to our SpringDouble, our concrete version of the Spring value, where value is hard-coded to a double, and just eradicate it. And once I do that, we'll see we get a couple of errors up here. SpringDouble was used inside of animated, so we can just go and replace double with value. So this will contain a Spring value. And of course, this needs that type parameter there. So we'll add value to both of these instances. And then value is not in scope, so we'll have to add it to our struct up here. And then of course, we also need it to conform to Spring Value Protocol. So let's add that protocol requirement up here as well. And then the last couple of changes is we'll accept instead a value, not a double, and therefore we will also return a value, not a double, and set a value to our wrapped value property. And now this compiles, and not only does this compile, but so does where we're already using it. And that's because we've already implemented the Spring Value Protocol for our double here. So we've abstracted some stuff, but it's a pure refactoring, nothing has really changed. But now we're better situated to improve this API dramatically. So in order to see how we might do this, let's go into our circles view. Right now it's accepting this offset double, but maybe we could change this instead to accept a CG point, which has both an X and a Y parameter. We can use the Y parameter as the offset Y, and instead of using the X parameter as the X offset, which does make logical sense because I'm working in this constrained vertical iPhone-shaped slice here, let's actually be a little silly and use the X parameter as the diameter of our circle. So we could animate this between size 50 and size 100. And so with the call site, we will change this X parameter between 50 and 100. Okay, so now I'm going to scroll back down to our point of use. I'm going to comment out our custom offset spring version. I'll change this to a CG point, and we'll start it out as the X parameter being 100, the Y parameter being 200, and now we cannot simply multiply this by -1, so I'm going to add one more piece of state here, just called isBig, make it a bool, start it out as true. If we are isBig, we're going to set our offset to a particular value here, CG point 50, -200, otherwise we're going to set it to 100, 200. And now we can toggle isBig at the end of this, and when I re-render, we'll see that our circle shifts in Y positions and that its diameter changes between 50 and 100. So now let's also try to do the same thing with our offset spring. The first thing we're going to need to do is to change this to a CG point, and I'll simply copy this value over. And now we're getting a compile error saying that animated requires that CG point conform to our spring value protocol. So let's go up and actually add that conformance for CG point. So it's going to look very similar to our double extension. I'm going to say extension CG point for spring value protocol. And we're going to need to implement everything. So static func plus, this is not defined on CG points. So the left-hand side will be a CG point. The right-hand side will be a CG point. It will return a brand new CG point. And for this to work, we're going to have to construct a new CG point from scratch, adding together point-wise the X parameters and the Y parameters. So there's plus, minus is going to be very similar. And with CG point, we'll actually get a better idea of why that plus equals optimization is actually worthwhile. So we're going to need an in-out left-hand side parameter. We're not going to return a new value. And with this implementation, we can actually just take our left-hand side and add the right-hand side's X to the left-hand side's X. And same with the Y parameter, and do this in place. And we can see now why this is more efficient. In the normal plus version, we have to allocate new memory for this new CG point versus just being able to modify an existing CG point. So definitely a worthwhile optimization for something we're going to be doing 60 times a second at least. And now we just need our final two methods scaled by, in this case, we do need to construct a new CG point. So we'll just take our existing X multiplied by the scalar, and the existing Y multiplied by the scalar. Note how this is a function on an existing instance of CG point versus being a static function, sort of just nestled on the namespace. So here we can refer directly to X and Y, and we actually don't even need the prefixes. And then finally, 0, we can just make a new CG point of 0, 0. And of course, that has to be a CG point. And now CG point is conforming to Spring Value Protocol. It looks like all of our compilation errors have dissipated. And so let's see if this works. I'm now going to bring back in our second circles view, passing in our animated value here, and it works, which is pretty damn cool. So to recap, we've constructed this very nice high-level animated property wrapper that now works with not only doubles, but anything for which we implement this Spring Value Protocol. The final blemish is here. We do not want users of this library or ourselves to have to manually update these animated properties with a timeline view in the background of every view in which we use one of these things. That's very low level and finicky and just ugly. We shouldn't have to think about this at all. But the question would be, how could we get that to work? There's no getting around some hard requirements, which is that we do need to update that animated property calling update on the spring value once every render. We just don't want to have to do it explicitly explicitly like this. Further, we might have multiple views that all have animated properties, and we would like to, in some global way, efficiently update those properties if they should be animating. And if nothing should be animating, we don't want to be rendering something or calling update on those frames in which no animation must take place. For instance, currently right now we're calling update every frame, even now, as the sphere just sits statically on our screen. Really, we only want to call update once an animation is triggered until it comes to some rest. So those are two problems we can solve. The biggest one is obviously this explicit calling of the update method using this timeline view hack. So to be even more specific about our need, we need a way of registering some callback, some piece of functionality, the update method, for instance, to be called 60 times per second, or 80 times per second, or 120 times per second, however quickly the screen refreshes. And it turns out that there is actually another, older, built-in way of doing this that predates SwiftUI and Timeline View. And this is something known as a display link. So what is a display link? Let's take a look. We're actually going to be building our own let display link. It's actually called a CA display link, and we can look at its documentation here. So CA display link is a timer object that allows your app to synchronize its drawing to the refresh rate of the display, which is pretty much exactly what we want. And there's some details here in the overview about exactly how we might create it. Here's a little code example. So we can instantiate a display link, and it uses a bit of an older kind of syntax that we don't use too much in SwiftUI. We'll basically need to construct some sort of reference type, some class, which will be the target, and then create a selector to one of its functions. In this case, we're selecting this step function. Then we have to call this method on the display link, adding it to some run loop. And basically what's going to happen from here on out is this method that you registered with that display link is going to be called however many times per second the screen renders at. And there's some details and some configuration, and you can have a minimum and a preferred and a maximum frames per second. But essentially this allows us to hook into our device's frame rate and render at just the right number of times per second. So let's just start out by proving that this is indeed the case. I'm going to actually make a class called DisplayLink, taking advantage of the fact that the built-in one is called CA DisplayLink, and I'm going to make a function in here called, I guess, setUpDisplayLink. I'm going to make a variable called DisplayLink, which is going to be an optional CA DisplayLink, and in here I'm going to set it to CA DisplayLink. The target will be self, this class, this instance that we'll have eventually, and we'll need some tick method, some method that's going to be called once per second. It was called step in that example, so I may as well steal that name, and it's going to receive as an argument the display link itself, which we don't really need because we have it here, but why not? I'll call it link CA display link. At least it will be non-optional in here. Then I'll use this magical hashtag selector and select step. Now the function that we refer to must be an Objective-C exposed method, so we have to basically just follow this hint, which will throw in the @Objective-C attribute here. We don't even need to worry about that. Yay, hints. Once again, this is a much older API. And cool, now we can print in here. I'm stepping. A couple of more steps. We're going to want to make a global singleton value of this that we can share everywhere. So I'm going to say static let shared and just instantiate one of these display links. And then here in our content view, I can throw an onAppear modifier. And in here, I'm going to grab our shared display link and call setUpDisplayLink. Which reminds me, I forgot to do the other important bit of boilerplate, which is to add it to a run loop. So let's add it to the current run loop for the common mode. And now that we've done that, I can run the preview, open up the console, and we see a whole bunch of logs are getting output. It's hard to tell exactly how many logs, but it's certainly calling this method a bunch. And if we want to print out some more info, well, Link actually has some fields on it, including duration, which is the time interval between refresh updates. So that's basically our time delta from before. And we can see it's that same value of 60 times per second, essentially. So this is the answer to all of our problems. We're going to want to somehow connect these animations to this global display link and have this update them. Let us begin with a maximally naive solution and improve it from there. A trusted strategy. So one problem is that display link and its step function in particular has no knowledge of all of the animations that will be used throughout our program. We somehow need to tell this display link that we want to animate something. We sort of need to register our animations with this display link. So how do we want to implement step? Well, one way would be to have somewhere in our display link a bunch of animations. We'll think of exactly what this type should be in a moment, but it's something like a spring value, perhaps. One problem with this, as we can see right away, is that spring value is generic. So what can we put there? We might have spring values of doubles, some of rects, some of CG points. Display link doesn't really care about the exact values that will eventually be generated. It just needs to call the update method on each of them. But if we somehow did figure out a way to get those spring values in there, we could loop through the animations and basically call the update method, passing in that link duration as the time delta. And that's basically going to update all of our animations. The other half of this is, of course, we'll need to add an animation, somehow register an animation, which I guess right now we'll keep as spring value, and we're going to simply append it to that list of animations. Same problem, spring value requires a type parameter. Let's not worry about that at this very moment. So the next thing we can tackle is, when would add animation be called? Well, what about when we call animate on a spring value? We can simply get our display link, the global one, and add ourselves. One problem with this is that every time we click on our little circle here, it calls animate to a new value. And currently, if we add an animation every time, we're going to have that same spring value in this list of animations multiple times, and therefore we're going to call update on it multiple times, and that's going to cause the animation to go haywire. So we actually want to ensure that every spring value is in this list exactly once. One easy way of doing this would be to give actually every spring value some form of identity. So I can give every single spring value a UUID, which is unique. And then our animations can actually be a map from the ID to the spring value. And now instead of appending, we can just grab the animation's ID and then assign that animation to that key. And now that this is a map, we'll have to say animations.values. But nothing is really compiling. We can't really get away with using our generic spring value type here, unfortunately, because we're going to want spring values with different internal values. And there's no real good way of saying, I don't care. One very simple way of solving this, though, would be to actually use a protocol. There are only two things we really care about when dealing with our spring values from the perspective of display link. Display link only cares about the fact that our spring value has an ID and that it has this update method that accepts a time delta and will somehow mutate the underlying animation. So why don't we make a new protocol, call it animated protocol. We'll need an ID, which is a UUID that we can get, and we'll also want a function called update time delta that takes a time interval. So instead of requiring these spring values, we can require instead a bunch of animated protocols. So now display link is happy, but we've shifted the sadness over to spring value because it does not conform to animated protocol. But that's rather trivial. I just add the conformance and it's happy because it already has those required methods on it. So now the question is, will this work? Well, I'm going to click and we'll see that our right-hand side animation is super fast. And that's only because we can now delete this hacky background timeline view. We were basically animating twice, updating twice per render of the screen. Once we remove that, the response should look a little better. Now, if we pay close attention, you will notice that the animation on the right, which is our custom animation, is a bit herky-jerky, which is unfortunate. It seems that if we have this animation in the same view as a default animation, we experience some hitches in our frame rate. If I disable the other animation, everything looks nice and smooth. This came as somewhat of a surprise to me, yet it is unfortunately one of the constraints of working with SwiftUI. You have to play by its rules. That doesn't mean that all hope is lost exactly. Firstly, I'd argue this was a fairly interesting intellectual exercise for gaining a deeper understanding about how Spring animations work. Internally, SwiftUI is using some kind of display link type piece of code. The issue with our implementation, unfortunately, is that there are a few extra hoops to jump through. Our animation is facilitated in the following way. When this view renders for the first time, we set up the display link, which we'll call that tick method 60 times per second. And then once we tap on our circle friend, the tap gesture will change our offset spring, which will register its animation with our display link. and then that will start getting animated 60 times per second. I should mention here, actually, if we print our time delta, link.duration here, and if I bring up the console logs, even if I re-enable the other animation and render this, we'll see that it's actually still rendering, or at least calling that method 60 times per second. So that's great. Yet we can tell by the way this is a little staggered in its jumping between these 2 points, that even though we're updating the right number of times, the view itself might not be re-rendering exactly that number of times. SwiftUI simply doesn't give us that level of control. It seemed to be smoother when we had that timeline view. So there's this strange negative interaction between our animation with regular animation. So yes, that's a bit of a constraint in this custom animation system, which I unfortunately discovered a little late in the process. Now, there are some ways around it, whether or not it's worth it, whether or not there are some other further complications that have yet to be discovered. Those are open questions. I think many people have observed the fact that it's quite difficult to have your cake and also eat it. You want to use SwiftUI and play by some of its rules, but not all of its rules. You often run into awkward corners. You either have to sort of rebuild everything from complete scratch. In this case, we're still hoping that the Swift view would interact with our animations in a nice way. And it turns out that that hope was somewhat dashed. For whatever reason, and I don't fully understand why, doing things with that background timeline view seemed more promising. So perhaps we could actually abort the CA display link method, although it's interesting and certainly a nice bit of Swift and UIKit trivia, and still relevant somewhere in the stack of SwiftUI, I would imagine. It unfortunately has this odd interaction. Maybe there are ways around it, but I haven't been able to discover anything just yet. But I'm not going to give up, no. We can actually still achieve a pretty decent API. We can in fact still use this display link class. We'll simply change it a little bit. We'll firstly remove the display link, remove setting up the display link, change this step function around to instead accept the time delta directly, which is a time interval. So this will accept just a time delta. And it makes no sense to call this display link anymore. Instead, maybe we could call this animation manager or something. That might make more sense. And then I'm going to scroll down here, get rid of this. Goodbye, display link, you have failed us. And we can think back to our timeline view, which seemed to actually render at a reasonable speed. But we're going to tuck it away a little bit and use it with this animation manager so that we can still define our view like this and don't have to embed that timeline view ourselves. We can sort of export it as part of a library. What I'm going to do is I'm going to make myself an animation manager modifier, which will be a view modifier. And this will hold on to our manager, which will be that shared manager. We'll implement the body method that's required for view modifier. And in here, we will have our background. And within that background, we will have ourselves a timeline view with an animation schedule. Take the context here. And in here, we can do something as we did before, which I believe was having a clear color, just so we could have ourselves an on change of the context, date. And then in this block, we can calculate the time delta. In order to do this, we'll need to hold on to the last time that we rendered. So I'll say last render date, and we'll make this an optional. And the delta will basically be the context's date, time interval since the last render. Of course, that's optional, so I could just say last render or else now. Then we'll have to set our last render equal to the context date. And then we can call our manager's step function with that time delta. So basically, we're going to use timeline view once again to render our view 60 times per second, or 80 times per second, or whatever the refresh rate is. And with that in place, we can scroll down to our content view, and we can add as a modifier our animation manager modifier. That's a bit of a mouthful. And with that there, everything is smooth again for some reason that I really can't explain to you, except perhaps this method here, this callback here, it's seemingly called the same number of times. We looked at that before, 60 times per second, as was the callback we attached to our display link. The only difference might be when this callback fires. I'd imagine SwiftUI is calling this at some point in its render cycle that allows it to react nicely to the change of state. That's really the only theory I have at the moment. And to finish this off, we can actually still solve that problem, which is the fact that if I do print the time delta in here, we're going to see that it's calling over and over again, even though there's nothing being animated. So how can we fix that? Well, it turns out this animation schedule has an optional paused argument. And with this, we can determine whether or not this callback is firing. And what we could do is actually check to see if the animations map is empty, then we're paused. Otherwise, we can run this. So if I bring that preview back, and if I print that time delta, if I open up the logs, we should see nothing until at least we click on one of these, at which point that Spring value will add itself to the animation manager, and therefore now it's getting animated. Of course, the problem is it never ends, so that's the last thing to fix, really. I'm going to remove that so we have more room, and let's think of how we can possibly fix this. Let's scroll up to our animation manager, and basically what we want to do is after we update our animation, we want to see if this animation is done, then we can remove it from our animations. Remove value for key animation.id. So now we'll just need to add that member to the animated protocol. So let's jump up here and say var is done, which will be a bool that we can get. And then, of course, Spring value needs to implement that method. So how would we determine if our value is done? Well, we can check to see, is our value at its target? But not only that, is the velocity also at 0? Because perhaps the value passed through the target somehow very luckily, but is still traveling quite quickly and hasn't yet settled. But if the velocity is 0 and the value has reached its target, based on everything we learned about spring physics, that's not going to be moving any longer. So how do we do this? Well, we can get our displacement, value minus target, and then we could basically just check, is velocity equal to 0 and is displacement equal to 0? And of course, for this to work, we'll need to add equatable. So we can go up to our Spring value protocol and say that Spring value protocol must also be equatable. And then yes, I need to have a return here. And now that we've done that, let's see what happens. Actually, first I'll say is done, removing animation, animation.id. And here I'll say stepping animation ID, and we'll throw the time delta in here. And then I may as well also say adding animation. So with that all in place, let's look at our preview. I'll bring up the console, clear out those old logs from before. And now we see nothing. When I click, we should see some logs getting printed until the animation comes to a stop and it is removed. So I've been waiting for quite some time, yet it is not yet stopped. So what could be the problem? Well, let me cancel that and we'll scroll up. So it appears to be the case that is done is always false. And if we scroll up to our implementation of is done on Spring value, perhaps we're confused. Isn't the whole point of this Spring animation to bring the value to the target? Shouldn't that eventually reach 0? Well, let's confirm that suspicion by printing the displacement. So I'm going to rerun the preview, bring up the console, click on one of these, and oh no, it is not reaching 0. It is stuck in floating point hell. Notice E-14. So we have a very, very, very small value, but it is not reaching 0. Therefore, will never be done. So let me get rid of this. And so what we actually want to do here, and what is actually done in SwiftUI, is we want to check that it is approximately 0. So there's generally this value called epsilon, which is a very, very small number. I'll say epsilon just for fun, because it's nice to say that. And we'll make it, I don't know, 0.005 or something. We can play with that. And then we can see, instead of checking that the value is equal to 0, we can see, is it less than epsilon? But of course, this is weird for a couple of reasons. Displacement and velocity are values. We could compare them against 0, because 0 was also a special value on our protocol. But here epsilon is a double. There's the additional problem that, well, displacement and velocity could both be negative. This could be traveling in the negative direction. And so because of that, there's actually one last method we'll want to add to our Spring value protocol. At the same time, we can actually get rid of equatable. We're not going to be needing that where we're going. In fact, it turns out that Spring value protocol is actually just a poor man's version of vector arithmetic, which is part of SwiftUI. It's a protocol, and it's a type that can serve as the animatable data of an animatable type. It extends additive arithmetic with a scalar multiplication and a way to query the vector magnitude of the value. Complicated things. Let's break this down. Additive arithmetic is simply a protocol that allows plus equals, minus equals, etc. And it has 0, so that's basically part of what we've collapsed into Spring value protocol. And then vector arithmetic adds scale, which can multiply whatever that value is by some scalar double. There's some other interpolate values which we're not going to worry about. We don't need these. But this one, magnitude squared, is interesting. It returns the dot product of this vector arithmetic instance with itself. Sounds kind of complicated, but let's steal it and see why it's useful to get us out of this bind. So I will add it to our Spring value protocol. It's going to be a get, and it turns out that double has that method on it already as well. CG point does not, though. So what does it mean? Magnitude squared. Well, it said the dot product of this vector arithmetic instance with itself. Basically, what we want to do is go through each value and square each value and then add them all together. So the sum of the squares. And really what this is going to allow us to do when trying to check to see if our animation is done or if a value is close to 0 is, well, the squaring of each value is going to remove any negative values, so everything will be positive, and then we're going to sum them together, which means that basically this resulting double will represent the sort of sum deviation from 0 across every value in our type. And so this will help us implement is done, so we can check to see whether the magnitude squared is less than that magical epsilon value. And with this in place, hopefully, please, universe, I will clear out our logs, I will click, and we are done. It removed the animation. And we're so very close. There's just one last thing to look at. If I click again, keep your eyes on the right-hand dot, well, it sort of explodes. And now if I click again, the right-hand side is basically busted for a time. The longer I wait, the more it becomes busted. If I animate very quickly, it seems to work, but if I wait for a moment after it's done, it responds quite frenetically. The reason for this is because of our little fancy animation manager modifier. We're storing this last render date and we're using that to determine the time delta. The only problem is if our animation finishes, well then that last render won't have been updated since the last time. So the last thing we want to do is on change of the manager animations.isEmpty. So basically I can get the old value, new value in. So if new value, i.e. if is empty is true, if we are done, then we could set last render equal to nil, and we can make this a bit terser using the $sign notation. So let's try this. I'm going to bring up the logs, I'm going to clear them out, I'm going to click, we'll wait for it to finish, it's done, clicking again, it's done. We have finally done it. And this seems to work okay. It's a nice smooth animation, and we have full control over velocity and everything. Now, is this production grade? Perhaps in some situations. It is unfortunate that SwiftUI doesn't really give us all of the information we might want, but, that's the world we're living in. I, nonetheless, had fun working on this. I hope it was educational. This video was certainly more of an odyssey than I intended it to be originally, but, it's fun to go off into the weeds sometimes. And if you've been enjoying these videos, please do, click on all the buttons beneath the video, the ones that would possibly fill me with joy, ideally. And also, let me know if there's anything in particular you'd like me to cover in the future. Any topics or questions you might have. So until next time, I don't really know. I don't have a catchphrase. Until next time, have a good life and be happy. And see you around.